Hi everyone, in this demo we present our tool that automatically detects for likely design flaws in entire object-oriented architecture. Entire architecture is a recommended industry practice as it promotes separations of various concerns into layers. One commonly used in entire architecture is the separations of class into three stereotypes, namely boundary, control, and entity. Class stereotypes are not just symbols, they come with design rules governing their behaviors and responsibilities. If natures of class is not apparent to developers or its behaviors do not match its stereotype level, developers are prone to make mistakes, violating the rules, especially as the code evolves over time. There are two common rules variant: robustness rules and well-formedness rules. Unfortunately, many software projects during development or maintenance have little documentations. Many design documents, including those specifying stereotype levels of the class in a program, are often missing. Such information is not obvious in the source code either due to poor variable and/or class naming, code changes, etc. Also, keeping design documents and stereotypes up to date manually could be time-consuming and error-prone. We implemented our proposed system as an Eclipse plugin and have tested our tool on a number of student projects and real software systems. Our validation detection framework to infer class stereotypes are as shown as follows. It has two phases, namely training and testing phase. In the training phase, we build a statistical model using a machine learning technique that can discriminate the class stereotype based on a set of class with given stereotypes. In the testing phase, given a class or a program containing more than one class with no stereotype levels, we predict the corresponding stereotype for each class based on the model. There are 5 different processes in the framework. First is extraction of basic information, then follow features constructions. This process is applicable in both training and testing phase. Then there are model learning process combining feature construction in testing phase and classifier from the training phase, followed stereotype assignment, and finally violations detections. We implemented our solution as an Eclipse plugin. The plugin consists of an additional button in the Eclipse toolbar. In this button, there are multiple options presented to the users: training and checking for design flaws, using either robustness or well-formedness rules. Now we would like to start to train a model. Once a user starts the training phase, a dialog box will appear to ask for the jar files for the project along with files containing stereotypes label for the various classes in the projects. Users may add more than one set of jar and stereotype labels. When you're done, click the Train Model button to continue. Once our system is trained, it could be used to detect for likely violations of well-known design rules. When you're ready, choose the selected project, then click the button to choose the Checking Design Flaws options. In this demo, we choose robustness. Internally, our system will compute likely stereotypes of the individual's class based on an internal trained model. This is transparent to the users. The stereotype in turn would be used to detect for violations that would then be reported to the users in additional tab at the bottom of the Eclipse IDE. User could then click any of the reported violations, and our systems would bring the users to the code containing the likely design violations. As a summary, we learn a statistical model to distinguish the various annotation of a class from a training set. This model in turn is used to give labels to the remaining non-annotated class. Likely design flaws are later detected by finding violations of well-known design rules. Our system has been implemented as an Eclipse plugin. Preliminary experiment results on several small and medium scale.